Hello and welcome back. Today I have something very exciting for you. We want to talk about data visualization. So until now we've been working with text mostly. We didn't do any graphics or anything like that. But this is actually very easy to do in Python, and graphics is handled very nicely by this Colab environment. It can be printed just where the output of your program is. Colab can print graphics. And this is very nice because you can do all sorts of visualizations, you can do diagrams that are a lot of fun, that look nice, and that give you insights. And so let's today just try this. And the library we're using is called Matplotlib. This is one of the standard libraries used for this job. And the core idea of this is that you build your plot that you want to plot layer by layer. First, you have your data. Your data is always in lists. So you have typically two lists. You have one list of values for the x-axis and one list of values for the y-axis. You pass these two lists of values to a function which then creates a plot for you where it plots the x values against the y values. And so this is the main function. But now you can use other functions of this Matplotlib library to add decoration to your plot. So you can add labels for the axis, you can choose the scaling, you can add colors to it, you can choose what kind of plot you want, whether you want a bar or a line plot or a scatter plot. So there are all sorts of changes that you can make there to make things more interesting and look better. And it really does look very professional what you get at the end of it. So the basic anatomy of a plot, what you normally have in a plot is here, wait a moment, let me center it properly. So what you normally have in a plot is a figure. The figure is just the frame in which the plot will be printed. This is so that you can scale the whole figure, right, without changing the contents. Then you have the axis, where you can label the axis, or you can say what values the axis should have. You have the plot type, where you choose, do you want a bar plot, a line plot, a scatter plot, and you have title and labels in your plot. So let us see a simple example. That's one of the easiest examples. Sales of fruit in your supermarket. You have to import Matplotlib, and usually if you look at examples all over the internet, they import it as PLT. PLT seems to be kind of a standard abbreviation for plot, and you can just use that, but you don't have to. You can import it as whatever you want. You can import it as George if you want, right? You can give it any name that you want. If you use PLT, you will not confuse other people so much if they read your code, because they know what to expect. Okay, import matplotlib.pyplot as PLT. That's the standard invocation how to import it. Just do that. Then we need to prepare our data, because we need, I said already, one list for the x-axis, one list for the y-axis. So my products are for the x-axis, and I have a list with 3 products: apples, oranges, and bananas. And then I have my y-axis. My y-axis are the sales of these 3 things: 150, 95, 220. So, pieces perhaps of apples, oranges, and bananas. The important thing is the 2 lists have to be of the same length, right? Because you want to have one data point for each pair. An XY pair gives you 1 data point, so they need to come in pairs, otherwise you don't have any data points. And now we want to add some elements with it, so we call the bar plot, which is PLT, our plotting object, dot bar, and we give it these 2 lists, products and sales. This will create our plot. We add a title, weekly sales by product. We add a label, units sold. And finally, we show the whole thing. So it is built in memory first, and then we have to show it so that it actually appears. Let's just do this. Very easy, very primitive plot, but you see it already looks quite nice. So we have our title, weekly sales by product. We have our graphic. We have our labels here, and we have the apples, oranges, and bananas as bars. Now, you see, we didn't have to do anything in terms of colors or sizes or whatever. It's all automatic, default values. The bars appear in blue, and the size is just so that it matches your output area, and the units sold here are automatically chosen because of the values we have, right? We have these values that go up to 200, so the Python knows to give us a plot that goes to 200. You can change all these things, but you don't have to. This is why it's so convenient, right? You can just use it. Now let's do another word frequencies plot. What we do here is again more or less the same thing. Matplotlib, pyplot as PLT, we have to import it. Then we have a piece of text, is only a few words, so there's not much in terms of word frequencies here. It would be more interesting if you add some words, if you give a longer text here, but it doesn't matter. We're not now really counting anything useful. We just want to see how to make a plot. We have to clean the text up a little bit, right? We lowercase the text, we replace the comma with nothing. We split the text into words, which produces a list of words. So now we have a list of words. And the list is, if you remember, exactly what we want, right? Because we need the list in order to plot it. We create our new dictionary of word counts. And this whole word counting business we've done before. So go back to the previous video, I think, or 2 videos back, which explains how to do text mining. And there we did word counts. It's exactly the same code. So we go through our words list, which we created here, words, right, by lowering the text. And for every single word in this words list, we update the count in this dictionary by going to the position word, getting the word there, and adding 1. And now we have all our words in the x-axis, and we have the counts for the y-axis. So we get the keys, and we want the keys as a list, because you remember that Matplotlib always uses lists to plot things. So we have to convert it to a list, right? And so we get the labels here, which is a list of the keys of word counts. And values is a list of the values of word counts. Now we want to create a figure of a specific size. Previously we did not do this. We got the default figure, and if you remember, let me scroll up a little bit, it's pretty big, right? It doesn't really fit into here very well. So now we make a smaller one. And let's really make it smaller, because this is still pretty big. What these numbers specifically do is, better see them as relative numbers. I don't know if the documentation somewhere says if this is supposed to be centimeters or inches, but this wouldn't matter really, because as you see here, for example, in this Colab environment here on my browser, I can just scale the whole browser, right? I can make the fonts bigger and smaller, and then I also make the graphics bigger and smaller. And if I project this onto a wall, right, on a projector, then again, it's different. The centimeters are not centimeters anymore. Now they are, meters. So depending on how you project it. And therefore, these numbers don't really mean much. If you print it on a piece of paper, it will be different size again. So just use them as relative numbers. See what comes out when you plot it. And if you don't like it, use smaller numbers. Now we create the bar chart. Again, a bar with the labels, the values, and the color sky blue. So now you see we can assign a color to that. And we add some labels and titles, and we display the plot. So let's just do that. We execute it, see sky blue, and now we get a diagram that is a little smaller. Let's make it even smaller just to see the effect of the figure. Instead of 7 and 4, I would say something like 4 and 2. And we execute it again, and now you see we have a very small one. Of course, if you make it too small, as you can see in this example, you cannot anymore print your x-axis values because there's not enough space for the words. So perhaps we overdid this a little bit. We should perhaps go for 6.3 or something. And now we have a little bigger. It still doesn't fit completely. So something like 7 or 8 would have been right. Anyway, you see how this works. Our counts are not very interesting. They're only 1 or 0 because there's nothing else. The quote was too small, right? But you see how we can use this. So it's a very easy, very nice way to plot stuff. And we can also do line plots, and it's all more or less the same. I will go through this very quickly. You have decades here, and you have books reviewed in each decade. Again, a very simple correlation between two lists. I have a figure size for my plot. And here now you see I can do a few more things. I have my plot of decades and books reviewed, right? These are my two lists, are always the first parameters there. And then I have a marker. So I can also specify a marker. How do I want in my line plot, because line plots have markers between the line segments. How do I want there to make my dots on this line? And the O will make round dots. If I want square dots, I will put an S. I can have triangles, up and down pointing triangles. There are various ways. I can put stars. So whatever you want, look up the documentation for PLT plot, matplotlib.plot, and then you will see the different marker styles that I can use. Again, line styles are different line styles. That's a normal line. I can have a dashed line if I do it like this. I can have lines with alternating with dots. There are various ways how I can do this, and I can have different colors. In this case, I want to use green. You can also specify colors always as hexadecimal values like you do in HTML, right? So this here would be red, green, blue, right? For two digits are always red, green, and blue. And so this would be red and blue. So this would give me a purple color, right? But we said we wanted green, so let's leave it at green. We add titles and labels and we plot it, but we also add a grid. And the grid, now you will see what it does in a moment. Let me execute it. Here you see the grid, right? It gives us a grid which attaches to every tick of my plot. And this makes it easier for the viewer of the plot later to see where my data points are. So let's make it a little smaller. We hope that it can be a little smaller. Okay, so this fits a little better, and now you can see that we get all these points nicely on our plot. We can have a scatter plot also. A scatter plot for sentiments. Here we have various sentences. We calculate the sentiments with text blob, which, if you are not sure how it works, you can look at the previous video, which was a video specifically about text blob. We create our figure, and then we ask for a scatter plot, right? And there we have a subjectivities against the polarities in purple color. And what we do here is to add a horizontal line, which you can additionally do. You can add lines to your plot as you like at whatever place you want. And we add this at y equals 0. And this will just be a line that goes through the plot in a gray color. And it will be, as you see here, a dashed line that shows us where 0 is. So this is useful if you have your 0 somewhere in the middle of the plot, because you remember the sentiments go from positive to negative. So in the middle is a 0, so it's better for the user, for the viewer of your plot later, to know where the 0 line is. So we print it there. So let's execute it. And again, the rest of this plotting is always the same. Here we go. That's your 0 line that we plotted. And you see how the polarity and subjectivity relate to each other. I will again make it smaller. Let's go for 6 and 4, a little bit smaller to see it better. And you see that there is no big correlation between subjectivity and polarity. All my polarities are positive except for one that is very negative, but the subjectivity is all over the place, right? So it can be, subjective and positive or objective and positive. It's not like there's any correlation there. And this is a scatter plot. So a scatter plot is a plot where I have individual dots. Now, before we finish, very briefly, let me say something about the different plot types. So obviously you can have scatter plots like this. These are most useful if you have two values that are correlated in some way and you want to see the correlation. So you have the sentiment against the subjectivity, or you have, let's say, preferences for particular colors against age. So you have some data points on the x and some data points on the y-axis, and often there will be different measures of some value for different individuals that you are measuring, and you want to see some correlation between them. This is where the scatter plot is the most useful. Lines, on the other hand, when you have lines like this, these are most useful for time series, where you have something developing over time and you want to see, does it go up or down, or over space perhaps. You have, instead of time on the x-axis, you could also have kilometers from home, and then you count, how many trees you have seen at what space from your home, and this also would be up and down perhaps in the same way. Or how tired are you when you walk away from home, as a function of a distance from home. So these are numerical series that you want to print in a plot like this. Bar plots like this one are the most useful when you want to see amounts of different things plotted against each other. Like in the first example, we had the amount of fruit, and here we now have the amount of words, of different words, the amount of different fruits. So you want to compare one fruit with the other fruit in terms of amounts. And this is where the bar is useful, because, subjectively we are used to seeing amounts as mountains of stuff piled upon each other. So when something grows, we immediately get this feeling of an amount, right? Which is not the same when you see a line going up and down. This does not immediately suggest amounts. So when you have amounts of something that add up, you would use bar plots. And the last thing you might use are pie charts. Pie charts, we've never used them here now, but you can make pie charts with this too. And pie charts are most useful when you have a whole and then you're talking about parts of that whole. So you have 100% typically of something, and then you say, okay, how many percent of the total is this? How many percent is that? And these parts of the whole arranged as a pie chart give you an impression of how this whole thing divides up into its parts. So make sure you use the right plot type for your plots. We cannot discuss it more here, right? This would go too far. We're just doing Python. But roughly, parts of a whole is a pie chart, amounts is a bar chart, time series is a line, and correlations between two measures of the same thing over a number of things is a scatter plot. Of course, you can always use them differently. You can use them creatively if there is something where you find that a plot expresses something particularly interestingly, although it's the wrong type. Of course, you are free to do it. But if you don't want to surprise your viewers, this is roughly the expectation. Okay, so we are finished again. Thank you. Have fun plotting with Matplotlib, and see you next time. Bye-bye.